This is Qt 5 Design Patterns Section 10. This section deals with behavioral patterns, or how your program behaves. These are industry standards, so this is not Qt specific. We're going to talk about the chain of responsibility, which is a way of passing a request between a chain of objects. The command, which encapsulates a command request as an object. The interpreter, a way of including language elements in a program. The iterator, which sequentially accesses elements of a collection. The mediator, which defines a simplified communication structure between classes. Memento, capture and restore an object's returnal state. The null object, which is basically what do you do if there is no object? How do you act? And then the strategy, which encapsulates an algorithm inside of a class. The template method, defer the exact steps of an algorithm to a subclass. And the visitor, which is a little bit confusing, but it defines a new operation to a class without changing the class. Diving into behavioral patterns, let's take a look at the chain of responsibility, and it is exactly what you think it is. You have a list of objects, and whoever is working on the current problem has the responsibility, and when they're done, they pass it on to the next one. I'm going to use, I don't want to call it a complex example, but it's going to take a little bit of work here. We're going to use a password validator. Now, this is a great example because passwords have multiple parts to them that don't always make sense in the context of the other parts. So what I mean by that is a password can have a specific length, has to contain numbers or special characters, things of that nature. So what I have here is an interface called an iValidator. Simply going to say check, and then we're going to check the string, and then check next, and it's going to move it on to the next. That's our chain of responsibility right there, is check next. So let's go ahead and implement this. First things first, I'm going to go in here. QObject, QDebug, interfaces, iValidator, our interface right there. Let's go ahead and implement that interface. Right click. And we're going to just, you guessed it, implement that iValidator. Very, very simple. Let's go ahead and switch over to the source here. Now, just to save some time, you guessed it, a little bit of copy and paste going on here. So for our check, all we're doing is saying if the length is less than 8, return false, and then check next. So what we're really doing here is we're validating this password, and each check is going to return a bool. If it doesn't return false, it's going to say check next, meaning move on to the next object in the chain of responsibility. Now, check next is going to take that, and it's going to, you guessed it, find children at 0 or the first child. So really we're using the Qt parent-child relationship. So every time check next is called, it's going to say, hey, grab the first child. Can we cast that to an iValidator? If not, return false. Otherwise, we're going to say, take that child and have it check it, meaning we are now passing that chain of responsibility. Whew. All right, that's a mouthful. Let's go on to the number validator here. Again, going to whip through this fairly quickly. Just a little bit of copy and paste just to speed things up. And don't get too hung up on the actual code here. This will all be up on GitHub. Really what we're focused on is the design pattern here, the chain of responsibility. So the number validator is just going to say, hey, use a regular expression, and we're going to look for, you guessed it, does it contain numbers? And if regular expressions are a bit of a mystery, don't worry, I feel the same way. I actually don't feel comfortable working with regular expressions. So I use this website, regex101.com. Really great site, check it out. Let's see here. Exact same code, find the first child of this object. If it has it, call check. So we're just passing that chain of responsibility on to the next one, which of course would be our special validator. Special validator, no real mystery here. Let's go ahead and implement this. Bang. Bang, and let's go ahead and insert virtual functions of base class. We're going to do the iValidator. And we are just whipping through this as fast as possible. Again, Our special validator, same thing, it's going to check, it's going to look for any special characters. If it does not, it's going to return false, otherwise it's going to go on to the next one. And it's just going to keep going and going and going, and you can chain these pretty much infinitely if you really wanted to. So let's give this a good build, make sure we didn't goof anything up. And we're going to close out all these files just to clear up the little clutter here. Again, don't get super hung up on the code inside of these classes. It really doesn't matter as long as we're following this interface, which is simply check, return a bool, check next, return a bool. So this is our current check, meaning we have the responsibility, and check next is we are passing that responsibility on to the next object. Whew. All right, it's kind of a mouthful here. Let's go ahead and make a password validator using all of that. So we're going to see this chain of custody, chain of responsibility in action. I call it chain of custody sometimes, and I really shouldn't. All right, so password validator, QObject, finish. And we are going to just grab some includes. In case you're wondering why I call it chain of custody sometimes, there is another similar but not as good design pattern called the chain of custody, which basically takes the responsibility, confirms it, and then does some extra jumping through the hoops that we really don't need. All right, so we have our password validator. Really, this is going to be pretty straightforward. We're going to say bool, check. And value. And if you're wondering if this itself is a design pattern, well, you're absolutely right. You remember our hotel example from previous video where we take a complex process here and make it super simple. So this is where patterns can really overlap. And that's why I always cringe when somebody says, well, that's not the pattern, it's this, because you can actually interchange these patterns. Let's go ahead and let's add these in here. So I'm going to say length validator. Actually, we can shorten this drastically. We'll call this L validator. And remember, we're working with the parent-child relationship, so we don't have to mess around with append or insert or anything like that. Let's say number validator. And this is where we're actually creating our chain. So I want to say L validator. So this would be our root. It's actually not. Our root is this object here. But so this would be the start, and then on to the next one. Let's just keep adding these. So you can see how we're building our chain of responsibility here. It starts with this, but really our actual start is this length validator, and then it's going to move on to the number validator, and then on to the special validator. And we're setting the parent-child relationship for each of these, so we don't really have to do anything as far as memory management. Qt does it for us. I want to get rid of this warning because, well, warnings are just, well, not great. Come on. Does not want to work for me. There we go. So we're just going to use the QUnuse macro. For some reason the IDE wasn't working there. Now our password validator check, very, very simple code. All we really are going to do is take the code from, you guessed it, these validators, and we're just going to plug it right in here. Bang. Exact same code. This, however, is not following the iValidator interface. So this is the root, or the starting point. Very simple, very easy to understand code. Checking the password, make sure we have some children, grab that first child, cast it into a validator, and then just start our chain of responsibility. Let's see this thing in action. And let's go ahead and I'm going to say password validator, and let's say QString password, and this is where we're going to play around a little bit here. So I'm going to say hello 123 world, and I need a special character or two in here. Why not? Just some generic password. Don't ever use that as a password. That's pretty weak, actually. So I'm going to say bool passed equal, and I want to say validator check. And then we're just going to check our password. So what's going to happen here is we are going to make our password validator. We're going to say check, and it's going to go through our chain of responsibility here. So first thing it's going to do is grab its first child, which is going to be the length validator. The length validator is going to do its thing and grab its first child, which is actually the number validator. Same thing with the number validator. It's going to grab its first child, and it's going to use this special validator, which does not have a child, but you could keep adding these if you wanted to, make special rule sets. And it would just go on and on and on until it hits the very end. Save run. Let's test this out here. So, checking password, we can see our length validator, then the number, then the special validator, and then the special validator has no next validator. And it did pass its test. We can play around with this a little bit just to make sure our code's working. So let's take the numbers out of there. And you can see length validator fires off, number validator says checking for numbers does not contain numbers and does not move on to our special validator. So that, in a nutshell, is the chain of responsibility in action. The command design pattern is one of the most used patterns. You've probably seen it dozens of times and never realized it. It's also one of the easiest to confuse because it's so straightforward, people tend to over-engineer it. When you read the intent, encapsulate a request as an object, thereby letting you parameterize clients with different requests, queue or log requests, and support undoable operations. What? Really, the main takeaway here is encapsulate a request in an object-oriented fashion. So let's make this super simple. We're going to use the stock market as an example. So I have a bit of code here. First things first, we have an interface called iOrder because, well, if you know anything about stocks, you need some sort of order. We have the stock itself, and the orders is typically a buy order or a sell order. So this stock is very, very straightforward. Just has some getters and setters, and you can buy it or sell it. Now, the orders, the iOrder interface, you could buy the stock, which does exactly what you think it does. We have this iOrder interface, and then we have this execute function. And in execute, we are going to buy that stock. Sell order, the exact opposite. iOrder interface, execute, and we're selling the stock. Main takeaway here is we want to encapsulate all of this. So typically, in the old days, you would go through what's called a stockbroker. Nowadays, you go through something like E-Trade, which is essentially a digital stockbroker. Point being, all of this back end here is encapsulated, so you don't even have to think about it. That's the whole point of the command pattern. So let's go ahead and do that. We're going to say new class, and we're going to make a broker. This could be E-Trade or whatever you wanted to use. And once we get that in there, let's go ahead and fill it in. So first things first, add our includes. And let's go ahead and make some functions here. So I'm just going to paste a little bit of code. So we have add order, place orders, and then you guessed it, add order is going to hold an internal list of iOrders. And then cleanup is going to do exactly what you think it would. So let's go ahead and implement these. It's very tempting at this point to, well, you guessed it, over-engineer this thing. One thing you need to really slow down and think about is we are working with memory. Every time you see that little star, boom, we need to deal with the memory in some fashion. That's why the cleanup function exists. Let's keep this as simple as possible. Let's not use automatic pointers or anything like that. Let's go broker and bang. So when this class is destroyed, we're going to call cleanup. Let's do cleanup first. That way we make sure we have protected our application as much as we can. We're just going to, you guessed it, remove all those pointers and then go ahead and clear it just in case. A lot of people would argue you really don't need to call clear because clear is going to happen automatically, and well, you're absolutely right. I just do it out of habit. All right. Now that we've made sure we've done our memory management, let's go ahead and add these in. So I'm going to say QInfo, adding order, and then whatever our order is. Now remember, this can be a buy order or a sell order. It doesn't really matter as long as we're following that interface. Place orders is really where the magic happens. This is where the broker says buy, sell, buy, sell. You see the crazy people on Wall Street screaming at each other. So we're just going to say for each. And we're just going to execute every single one of these orders. So let's go ahead and grab this. And we're executing that order, and we're just going to say order.execute. Very, very simple code. There's really no reason to overcomplicate this. Really, the whole point of the command pattern is to encapsulate all the information you need to trigger it later. That's the keywords, encapsulate and trigger it later. Let's flip over to our main here, and we are going to add some includes. And let's see this command pattern in action here. So I'm going to say broker and QInfo. Sometimes I get typing a little faster than the IDE can keep up with. So we're going to add those orders, and then I'm just going to say broker, and we're going to add order, new. Whenever you see new, remember we got to manage that memory. So I'm going to say buy order, and we need a pointer to a stock. So I'm going to say new stock, and then we need a name and a value. So I'm going to say, and this is where I'm really going to screw things up, I need a stock name. Let's go AAPL. I think that's Apple Computers. Some people are cheering, some people are going boo. Just depends on if you love or hate Apple. And then we can take this same pattern here, and we're going to say broker add order. Now we're going to switch this to a sell order, and we're going to say I need a good name, Johnson & Johnson. Let's go ahead and sell 15 of those, and we want to buy ATVI. That's the company that owns Blizzard Entertainment Holding, if you ever play World of Warcraft. All right, so what do we have here? Well, we've encapsulated this very, very simply. So we can say broker, add an order. And it doesn't matter if we're buying or selling, and it doesn't matter what stock or what quantity. We make it very, very simple. Now we want to call that back. So I'm going to say QInfo. We're going to place the orders. And here we could say, I almost said execute, it's place orders. There we go. Very, very simple, very straightforward. The big takeaway here is do not overcomplicate this. You can make it as simple or as complex as you want it to be. So we're adding our orders. We're adding a buy order, a sell order, and a buy order. And then we go ahead and place those orders, and everything just works as expected. The interpreter design pattern is dead simple, and honestly, it's one of the most overly engineered patterns I've ever seen. Really, this is self-explanatory. An interpreter is going to interpret from one thing to another. It doesn't matter what it is. You could be interpreting a string to a number, English to Spanish, French to German, does not matter. It's just simply going to interpret. So in the spirit of not overcomplicating things, I'm not going to use an interface because I just have a class and I want an interpreter and I want it right now. I don't want to mess around with interfaces or anything like that. I can always do an adapter pattern later. So I'm going to say int interpret, and let's say, I'm coming up with an idea here. Let's say we're going to interpret a string. So all we're going to do is basically convert a string into a number, or at least try to. Then when we go in here, I'm going to say int value equals 0. I want to get the UTF-8 representation of that, so I'm going to say bytes, and let's say data dot to UTF-8, and then I want to know if I was able to actually convert this. But before we do that, I want to add a little bit of style to this. I'm going to say, and this may actually be me overcomplicating this, data starts with, we're going to test very basically to see if it's a hex format. All right, so now let's go ahead and say value equal, and I want the bytes to int and that's going to have a base of 16. And our little function here is just going to return -1 if we couldn't do it. If it is not hex, then we're just going to say we want a base of 10 and try and convert it that way, and then simply return our value. Again, there is this want or desire with most programmers to over-engineer or overcomplicate something, and I have seen some just crazy interpreters before in my lifetime, but in short, make it simple. It's one of the fundamental design patterns, is keep it simple. All right, we're going to say interpreter. And we want to interpret, and I'm going to say I want to convert 1, 2, 3. Let's just grab this, and we're going to do a bunch of these. And let's say 0x_c0. I'm just coming up with things randomly here, and why not? Let's just do a cat. Let's see what happens here. So we have our conversions here. 1, 2, 3 is 1, 2, 3. FF is 255, C0 is 192, 15 is 15, and cat, of course, would be -1 because it's not even remotely a number. So this works as expected. When in doubt, think of the interpreter as you need to be as clear, as simple, and concise as possible. Think of it as you're translating from one language to another, and you don't want any misunderstandings between the two people. Let's talk about the iterator design pattern. First off, what is it? It provides a way to access elements of an aggregate object sequentially without exposing its underlying representation. What? What does this even mean? Okay, so put simply, you can have an object in a, I want to say, a list of objects, and you can go forward and backwards through that list without exposing the underlying representation. Now I'm going to hit the pause button real quick here. I did not want to cover this, not because I think it's a bad design pattern, but because Qt does this for you most of the time. You won't even need to know this. It just works. So let's take a look. What are we talking about? Iterator design pattern. Why? It makes traversing a collection of objects super, super easy. You can see I have some templated functions. I have fill container, fill set, and fill pair. Those are the 3 types of collection classes Qt really has. And if we crack it open here, You can see I got them all ready to go. So for example, our buddy, the QList, it's a templated class, and it just provides a list. This is very simple to use. Now, even inside of Qt, things start to get muddy when you talk about what do you actually need, and that's why all of these classes exist. Each one fulfills a specific need. For example, QList is great if you just want to dump it in there and you don't care. However, even in their documentation, it says QVector should be your first choice because QVector is faster than QList. But you'll see time and time again, even in my tutorials, I'll use QList. Oh, that is frustrating. Now, why does that exist? Well, it's simple. It's a design pattern. There's always a better way. So QList, while it's not being superseded by QVector, QVector was created after the fact and is much faster than QList. And QVector was designed specifically because QList can get slow. So we have like QList, QSet. Now, what's a set? Provides a hashed table-based set. What does this mean? So a set provides very fast lookup of the values. So you can insert some things and then pull them back very, very quickly. Again, you got to kind of dig through the details to figure out what works for you. And to make it even more confusing, now you have QHash and QMap. These are key value pairs. And you got to figure out, again, hash table dictionary means fast lookup versus the QMap, which is the red-black tree-based dictionary. We're not going to go over the internal structures of all of those. You're going to have to do some homework and figure out the best solution for you. What we're focused on is the iterator design pattern. And using this, instead of creating a class and going through all of this complexity, you just let Qt handle the complexity for you. Typically, you would create a class or a Q object of some kind, and you would put it in one of these container classes. And, you guessed it, Qt handles it for you. You don't even have to worry about it. It's all done. Now, each one of these handles things slightly different, and that's the code that I've got keyed up here. Fill container, fill set, fill pair, and then I have display. So, let's take a look at these. QList and QVector, and actually, honestly, I should probably switch these around just because they have virtually the same API and they're interchangeable. I've heard rumors that QList is going to go away. I don't think it ever will, but I've heard rumors, cannot confirm those, and they're going to favor QVector moving on in Qt 6 and newer. So in our QList or QVector, we're calling fill container. In fill container, we're saying container append. Not sure why there's an extra tab there. Let's fix that. Now set, we're going to fill the set, and it's container insert. Now remember the difference between, say, a QList, a QVector, and a QSet is how Qt actually does it in the background, which is what makes it super fast or super slow, depending on what their classes are doing. And then you have key value pairs. We use fill pair for QHash and QMap. And we can just very simply say, display whatever we're doing, and then the object. And let's see this in action. So what are we really talking about here? Under the hood, what's happening? Why don't we really need to mess around with the iterable design pattern? It's very simple. It's baked right in. So you see we have a templated function here, and we're going to take a class called T. And under the hood, what's going on here is we're saying value begin, value end. And in the background, this is being converted to something like T iterator is going to be, for example, the QVector iterator or the QHash iterator or the QList iterator. It's all done for you. So you can put any type of object, be an int, a string, a Q object, some custom class in there. It will do it for you. And you just plop it in the container and you don't ever have to worry about it again. Now, buyer beware. Some of these are very simple and some of these can get a little cumbersome. And unfortunately, I can't answer all of your questions. There's going to be certain design choices you're going to need to make. For example, do you want the ease of a QList versus the speed of a QVector? You've noticed that I've used QList almost intentionally through every single video, and we haven't even really talked about QVector, even though QVector's faster. It's just simply a design choice. Should I use QVector? Yeah, Could I also use QList? Absolutely. So at the end of the day, choose the solution that works right for you and do not reinvent the wheel. The mediator design pattern is something that honestly you're not going to use very often in Qt because, well, you're already using it. That's right, it's already built into Qt. So let's take a look at it. What does this do? Define an object that encapsulates how a set of objects interact. Mediator promotes loose coupling, keywords there, loose coupling, by keeping the objects from referring to each other. Now what does that mean? It means those objects don't really depend on each other. They may not even know they exist. And it lets you vary their interaction independently, meaning you can change this at a moment's notice. Take a look at this graphics here. You have Jack, Larry, and Alex, and each one is going to do something which may cause the other person to do something else, and everything's all interconnected, and it's this big old mess. Try doing that in just straight C++ without Qt, and you suddenly understand why this design pattern exists. So if we're not going to really use this design pattern, what do we use? You guessed it, signals and slots. It's exactly why this exists. It's almost a direct replacement for the mediator design pattern. Let's look at an example here. We have a manager. Manager is going to say, hey, so let's start a project, guys. And it's going to say, everybody get to work. It also wants to know when that work's done. Developers, however, are going to say, hey, I'm going to create the programs when the boss says get to work, and I'm going to tell the boss when I'm done. Marketing is going to, well, I'm not even sure what the marketing department does, but I think they're going to create some hype. Send out advertisements, make, big explosions and commercials and loud bumpy music or whatever the marketing department does. And then when they're done generating all that hype, they're going to say, hey, I'm now finished. You notice how none of these know the others exist. Again, you're probably eye rolling because if you're in this class, you know exactly what signals and slots are. And good old copy and paste to the rescue. You don't have to sit here and watch me type all this out. We have our manager, we have our marketing department, and we have a QList of developers. You may be going, whoa. Shouldn't we be using QVector because it's faster? Doesn't really matter. To be brutally honest, this program's so small, I'm just going to use QList. Doesn't make the program any less of a program. It's not like it's sad and goes home and cries its eyes out. QList works just fine. So then we're just going to say for your 0, 5, make a developer. Developer works for the manager. And then developers append, and then we just connect our signals and slots up, and everything just works. So when in doubt, do not make this harder than it needs to be. Signals and slot works just fine, and as you could have guessed, it's a direct replacement for this design pattern. Now, in case you're wondering, why does design pattern even exist? Because this is a very, very old design pattern, and it's been around pretty much since the dawn of programming. I actually hesitate to cover the Memento design pattern because I really feel there's a better way than what I'm about to show. Well, then why am I going to show it, you may be asking? Well, I want to cover this in case somebody is following SourceMaking because I've been really hyping them up. So the Memento design pattern is, well, without violating encapsulation, capture and externalize an object's internal state so the object can be returned to the state later. Now there's a bunch of different ways you could do this. You could actually serialize the object and then hold these in files and then roll back to a different file. We're going to look at a very simplistic example. But basically you want a magic cookie that encapsulates a checkpoint. Promote, undo, or roll back to the full object status. So we're going to look at very, and I have to say very simple transactions. Now when I say there's a better way of doing this, later on we're going to cover the Qt state machine framework, and what that is exactly a direct replacement for this. That's why I really hesitate to cover this. All right, let's take a look. First things first, you notice I have absolutely nothing in here, so we are going to create a class. It's going to be a Q object, and it's going to be called Memento. And then from here, we're going to go in here and let's just go ahead and paste some stuff in. So we got commit, cancel, rollback, add transaction, command, which is a getter, I should say. And then we have a QString list of commands and the QString command. Let's implement these real quick. I actually do want to, rather than just the old copy and paste my buddy here, I do want to type these out just so we can explain what's going on in case this is somewhat new to some folks. All right, so we have all of this stuff. So first off, commit. This is when the user says, I'm happy with the modifications, go ahead and commit this, meaning make those changes. So I'm going to say mcommand, our string. I'm going to go ahead and clear that. And let's do for each instead of for. I'm going to say qstring, let's call this value in our string list. So we have a list of basically transactions is what we're calling them. We're going to do that down here in add transactions. So add, we say make this change, make this change, make this change. At some point we're going to say, okay, I'm happy with that, commit it. And that's what we're doing here. I'm going to say mcommand, append, and then whatever the value is. And let's go ahead and add some sort of separator. This is really custom solution here we're building. So it's just going to take all the strings. We could have done like a qstring list join, but I'm just doing it the long way just to really show what we're doing under the hood here. Cancel. This is when we say, hey, take the commands and wipe them out, meaning forget everything that I've told you so far because I'm not happy with the changes that we've made. So I'm going to say clear that out. You could also clear out this command just so we have nothing, but I'm going to leave it just because my implementation, I want to retain that last command. Rollback. This is where I want to say, hey, you know what? I don't like everything that I've done so far, so roll it back to its previous state. And I'm going to say mcommands, our list. I want to clear that out. But I want to roll back, so our previous state's actually held in our mcommand. So I'm going to say mcommands, plural, our list. We're going to go ahead and append the string that we've been holding. And it sets it right back the way it was. From here, it's very, very simple. We're going to add a transaction, which is just our string list. And as you can imagine, this is a very, very simplistic example. This can get super, super complex. Whenever you talk about state and state machine and state diagrams and things of that nature, I mean, we could sit here for months talking about it. All right, very simple. Just to recap, we can add transactions to our list. We can say, you know what, roll back to the original transaction, our last commit state. We can cancel and clear things out, and we can commit saying, you know what, I'm good with everything we've done so far. And yes, you could further simplify this. I'm just doing it for the sake of illustration. Let's go ahead and jump into our main, and let's demonstrate this. So first things first, let's do our includes, Keydebug, and Memento, the class we just made. And I'm going to say Memento, let's call this controller. And we're going to add some transactions. So I'm going to say controller. And I want to add transaction. I'm going to say hello. And world. You can add whatever you wanted in here. And then I can say controller. And we're going to go ahead and commit that. My keyboard has betrayed me. There we go. Now we can just take this, if we really wanted to. We could say stuff here and something like blah, 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 blah. Now, if we were to commit it, it would actually add that and replace it all together. However, I want to roll this back. So instead, I'm going to say, you know what? I didn't mean to do this. The user entered some garbage. So this is where the Memento part comes in, and we're going to say rollback. And if you remember correctly, the rollback code will clear out our list and then replace our commands list with the command that's in there. So it just rolls it back to its original state. Now you could further change this around and whatever you wanted to do, and you can make it super, super complex. Again, this is a very, very simple example. And we could just do a qinfo and Controller command. Let's get our last command that we've committed. So let's see this memento in action. Hello, separated by that world. Notice how our rollback worked as expected. You're going to see this pattern traditionally in things like databases where you would add transactions and then you could commit and roll back. But you'll also see this in other things, for example, network protocols and things of that nature. Personally, I'm not a fan of the null object design pattern, and here's why. It's too broad, it's too open to interpretation, and you can drive yourself crazy doing this. So the intent of the null object is to encapsulate the absence of an object by providing a suitable alternative that offers suitable default do-nothing behavior. What? That makes absolutely no sense. So if you have no object, you would have no behavior. But what they're saying with the null object pattern is have a behavior even if you don't have an object. Vastly open to interpretation, and you can see junior developers going crazy trying to figure out how to get around this pattern and how to make it work. So there are some general rules of thumb, but we're going to cover the cute way of doing it. So when I say the cute way, I have to kind of back up and say, I'm not really telling you the truth because this is so open to interpretation. You could do it millions of different ways. Cute, for example, in the queue object, right in the constructor uses this design pattern. If there's a parent, then Qt is going to assume the memory management. If there's no parent, then the default behavior is that either the stack or you are going to manage that memory. So if this were created as a pointer, we would not be responsible unless we set a parent. Okay, so there's one interpretation. This logger class, which is very, very simple, is another interpretation of this. So we just simply are saying we're going to log some string value, but we also have to set a file. Of course, we're going to go ahead and check to see if that file even is in memory and if it's even writable. But then what is the default behavior? So let's look at our code here. So we have our logger, log. We have not set the file at this point. What's the default behavior? Okay, here we've set the file, but the file's not writable because we have not opened it. So we have different levels of default behavior we could really look at. And this is what I mean by you can really over-engineer this if you wanted to. So we could take the easy route and say, okay, if there's no file, then let's go ahead and grab this and say queue warning. No file set. And then go ahead and return it out. And we could, again, do it here. File not writable. And we could have done this a billion different ways. So for example, we could also move this up here and say the default is we will always print something out on the screen, but we'll also give a warning if we can't write to the file. Or we could actually open the file on the behalf of the user. Like we could say, try to open a file here. And then we would have to define what's the file name, where are we going to put it, what are the permissions, things like that. And we could do all sorts of craziness. You can drive yourself absolutely bonkers doing this. So in short, the null object pattern is not my favorite because it's so open to interpretation, but you need to be aware of it because Qt does use it. Now, general rules of thumb when you're using this, my personal preference, yours may differ. I try to avoid this. If there's no object, I take no behavior because what you're really relying on is the lack of object defining the behavior. Let's take a look at the observer design pattern, and this is something that you've used over and over again, and yes, signals and slots to the rescue, but I want to slow down just a little bit here and really take a look at this pattern because you're going to see this over and over again, and you'll hear people talking about, oh, I used the observer pattern. What does it really mean? Well, you're going to define a one-to-many dependency between objects so that when one object changes state, all its dependents are notified and automatically updated. Boy, that sure sounds like signals and slots to me. And you can get into some really crazy patterns here. We're going to use this right here, the auctioneer. So we're going to auction something off. We're going to have multiple bidders. Whoever puts in the highest bid wins. There's going to be a time limit, all that. We're going to just check this out. So let's dive in here. Got just a blank project. So I'm going to create a person. This is going to be just, random person sitting at the auction house saying, hey, I must buy things. All right, let's jump in here, and I'm going to copy and paste some of this stuff. So we're going to have QObject, QDebug, QRandomGenerator, and of course we want to emit a signal saying this is our bid. Our slot is place your bids. This is when the auctioneer says place your bids, place your bids. So we're going to go in here, and let's go ahead and implement this. Now whatever this is, I don't care, whatever it is, I must have it. It must be mine. So I'm going to not going to use that variable. So want to get rid of that warning right up front. But whatever it is, I don't care what it is, I must own it. Just because I've got loads of money and nothing to do. So what I'm going to do is say, hey, grab some random amount of money because I don't really know how much this thing is worth. And let's just say I've got tons and tons of money here. Bounded between 1 and a huge number. I really don't have that kind of cash, but if I did, that's what I would bid on whatever this thing is. And then we're going to emit our bid to let the auctioneer know, hey, this is our bid. Very, very simple, very easy to understand. Give it a build, make sure we don't have any little gremlins. The auctioneer, though, this is where a lot of this pattern really takes place. So I'm going to say add new, class. And remember, we're going to define a one-to-many relationship. Qt makes this ridiculously simple, but of course there's going to be some code. So let's go in here. Going to get a lot of the drudgery out of the way. We're going to have QObject, QDebug, QMap, QTimer. So what the auctioneer is going to do is it's going to sell a thing, whatever it is, with a time limit. And they have to place their bids within that time limit. Here's our public slot bid. This is where the people are going to say this is what my bid is. And our slot timeout, it's private. That's our timer is going to call back on that. And then we've got some private variables, timer, limit, count, item, and our bids. And notice that's a QMap holding a pointer to a QObject and an int. You might have guessed this is the person. You are absolutely correct. We're going to grab the sender out of the bid. I actually had place bids. That's not the right one. It's out of bid. So let's go ahead and implement this. And let's go bang. I'm just going to do this very, very quickly. A lot of this code is very, very simple. And then last but not least, we're going to, you guessed it, pick a winner. So let's go ahead and we're in our constructor here. This is where we're going to connect our timer and set the time out. Very simple code. So when the timer times out, it's going to call this little guy down here. So while we're down there, what we're going to do is very, very simple. We're going to say time left, whatever. If that time is less than or equals 0, we're going to go ahead and pick the winner. Now, pick the winner, this is where some of this code gets a little convoluted, but it's not real worthy of anything. We're not going to win a prize. So anyways, we're going to stop that timer. Then we're going to say, hey, we're going to have a pointer to the winner, and then we're just going to go through everybody who placed their bid and say which one was actually the highest. If there are no winners, there's no winners. Otherwise, sold to whoever the winner was for the highest amount, and then we're going to clear the bids out. We've got two more little things. First one is the sell things. Let's go ahead and jump in here. And we're going to say the count limit item. And we're going to sell that item. The auction ends in however many seconds. We're going to start our timer, and then we're going to emit the place your bids. This is going to trigger the people to say, hey, place your bids, place your bids. And then they're all going to, you guessed it, place their bids. Lots of code. Didn't want to type all that out just because it's not really complex code and it really detracts from the design pattern that we're talking about. So I am going to prettify this. Is that even a word? Prettify? Beautify. So we're going to auto indent all that. Now that we understand how these two objects really interact, let's make them work. And again, signals and slots to the rescue. Qt makes this ridiculously simple. All we really need to do at this point is, you guessed it, have our includes, and then actually make our design pattern happen. And then we're going to say auctioneer. Let's call this sales. And then we want a queue list of people, but we're going to say queue object pointer. My keyboard has once again betrayed me. And we're going to say increment our counter. And in this for loop, this is where we're going to make our people. So I'm going to say person. Make the sales the parent. They're queue objects, so we can do that. And then I'm going to say P. And I want to set the object name, and then we're just going to say person. That way we just have some name. Doesn't really matter what we do. And then we're going to give it the number. That way we just name them like person 1, person 2, person 3. Very, very simple code. People append, we're going to go ahead and append that pointer. And then you guessed it, we are just going to connect those signals and slots. So I absolutely detest typing this out. I hate doing the connection code. I always do the auto connect in my own personal projects that we covered in the signals and slot section. But alas, we have to type this out, because I have vowed not to use that for these lessons, because some people will skip it, and you guessed it, they will start asking a lot of questions and they won't understand. So anyways, queue object connect, we're going to go ahead and connect our sales, and we're going to connect that auctioneer, place bids. Now I kind of really talk bad about the queue object connection, but it's really gotten much, much better than what it used to be. And honestly, I don't see how we could actually make it any simpler. All right, so now we're going to have person, place bids. So very, very simple. When the auctioneer says place your bids, the people are going to place your bids. And again, these people are drunk, happy, and rich, so they're going to buy whatever we put out for auction, because that's what drunk people do. Let's grab this. The good old copy and paste here. Now we're going to do the opposite here. We're going to connect our person, and we're going to say person, and we're going to say bid, and we're going to connect that back to the auctioneers. And we're going to connect that to our bid. Now, as long as everything lines up and we've got our signals and slots correct, this becomes very, very simple now. We just say sales, sell a thing. And what am I going to sell? I'm going to sell my cat, and I'm going to sell him for $5 whole. Why not? And everybody in the auction is going to say, I must own Brian's cat, and they're all going to place their bids. And we're going to count down. And sold to person 4 for, oh my goodness, that is one expensive cat. But you get the point here. We have a one-to-many relationship. It's very simple. One of the many downfalls of the pattern here is that it is so open to interpretation. It's very usable, but at the same time, very easy to break, because it can become something completely different just by making some small modifications to it. The big thing here about the observer pattern is this one-to-many relationship and the notifications in between, which of course just screams signals and slots when you're talking about Qt. I want to go over the state design pattern, but we're going to go over this at a very high level, because in the spirit of this course, there's always a better way. So when we talk about state, really fundamentally what we're talking about is the variables inside of an object make up that object's state. Now, the state design pattern says allow an object to alter its behavior when its internal state changes. The object will appear to change its class. This is deceptively challenging. It says allow an object to alter its behavior. Well, that's programming 101. Those are if statements, switch, do loops, things of that nature. The object will appear to change its class. Why would you want to do this? Well, there's many different reasons why, and I've seen this over-engineered to the max, to the point just trying to do this design pattern becomes a lesson in insanity, to be brutally honest. But there is a better way. So for example, the Qt state machine framework, we're going to cover in another section. I don't want to spend a whole ton of time trying to describe what this is and how to use it because I want to focus on the better way of doing it. The problem is you're going to run into this design pattern once you step outside of the safety net of Qt. And you're going to start seeing things like this where you have a vending machine state. And whenever you see some function that ends in state or you hear the word state, you should automatically just think to yourself, variable. They're really talking about the variables inside of a class. That's really all it is. Now, they have an overall checklist here. Identify an existing class or create a new one. You know, notice how right off the bat they're not even really being concrete about what they want you to do, but it will serve as a state machine, and that's why I said don't reinvent the wheel. Let's take a look here. So I've got some code already ready to go, and there's no sense in typing it because the code's simple. We'll walk through it super quick. We have an interface called a light, or I should say iLight. Sounds like something Apple would sell. We could power on, power off, change the color, which is implemented by the, shockingly, light class. And it power on, power off, changes the color. Now, I'm in America, so we have traffic lights, which typically have a green light, a yellow light, and a red light. And these do, well, absolutely nothing other than change the color. So we make all of that nonsense into our state machine, in this case the traffic light, which is going to combine the red light, yellow light, and green light. You see why I didn't type all this out. It's very simplistic. And we're going to change our state based off what color we have. So I just have this color enumerator. We can start stop, which starts and stops an internal timer. And here is our state. Now, this is what I wanted to focus on right here. It's very easy to break this, and you can spend all day arguing about whether this right here is actually even part of the design pattern. And this is what I mean. Go all the way back up to the top. The object will appear to change its class. This is where it gets super, super frustrating. The object will appear to change its class. Well, when we flip into our light, all we're really doing is when that timer times out, we're saying if it's green, switch the color to yellow, or if it's yellow to red, red to green, blah, blah, blah. In the switch color, we are actually switching the internal state. So if the color's green, make a green light. If the color's yellow, make a yellow light. Red, make a red light. So we are actually switching the internal state. But it's this little guy right here, the state function. To the outside world, that state will never appear to change because it's always going to be an iLight interface. So someone will argue this is not the state design pattern. Someone else will come in and argue it 100% is the state design pattern because we are changing that state and you can easily cast it into whatever object you wanted. Oh, that is super frustrating. And this is what I mean by I don't want to spend a lot of time on this because there is simply a better way, which we're going to cover in another section called the state machine framework. All right, seeing this in action, overly simplistic example, but it really drives the fundamental concepts home, is we turn on our light, it'll time out, it'll switch its internal state. You can see the current light is switching from green to yellow to red, and it'll just keep doing that over and over again. So the state of our state machine is now changing. Why would you want to use something like this? Well, traffic light is a pretty decent example, but there's also other examples. For example, if you wanted to do a transaction, is it a buy? When I say transaction, I'm thinking like banking transaction. Is it a buy? Is it a sell? Is it a deposit? Is it a withdrawal? You can have different classes and then based off that class, change its fundamental behavior. Let's take a look at the strategy design pattern. And this one, I gotta admit, it just annoys me. And here's why. The strategy design pattern define a family of algorithms that encapsulate each other and make them interchangeable. What? Okay, so strategy lets the algorithm vary independently from clients that use it. Capture the abstraction in an interface. It literally says make an interface and bury the implementation details in the derived classes. Oh boy, so really this should almost be called the interface design pattern. Whenever you see strategy, it's just an interface. So we go client, we have some type of interface, and then we have the concrete implementations, and we can switch those back and forth. Great example would be like transport to the airport. Our strategy is actually our interface of, let's call it iTransportation. It doesn't matter where we take a bus, a car, or a taxi, we still get to the airport. This is what also kind of annoys me about this. This exists because it kind of blurs the line between the other design patterns. So strategy is like a template method except in its granularity. State is like a strategy except in its intent. And it goes on and on about how each one's just slightly different. And it can intermix them. For example, strategy objects often make good flyweights. We talked about the flyweight design pattern earlier. So this is kind of nuts. And whenever you think of this, think of it in terms like this. It should be an interface, and it should be kind of the glue that holds everything else together. So let's jump in here. I've got some code already written. I've got an iWorker interface. Sounds like somebody that works at Apple, the iWorker. And they're just going to work. And then I've got a construction worker who's going to mix concrete and things of that nature. I have an office worker. And they're just going to like create spreadsheets and goof around all day. And then I have a surgeon. They're going to do things like, well, perform surgeries. 3 very different types of workers, but they all use the same strategy or the same interface. And that's why I'm a little bit annoyed that it is even a design pattern, but it exists for a reason. Back in the day when this was created, this was, cutting edge technology. So whenever you're around somebody, they're like, oh yeah, I created a strategy design pattern, just kind of roll your eyes and goes, okay, you made an interface and then you used it. That's really what you did. All right, so we're going to just go ahead and say QList. And normally this kind of code, I'll just be brutally honest, I would just copy and paste this, but this is part of the actual design, so we're going to do it. So say iWorker. So we're going to use the interface, and we've already covered interfaces pretty much in depth. There's really no secret what we're doing here. So as long as this class that we throw at it is this interface, it will work. So bang, just going to paste that in there. So for I to 0 to 100, then we're just going to generate some random number. Based off that random number, we're either going to make a new construction worker, office worker, or a surgeon. Doesn't matter which one. Default's going to be construction, just in case somebody comes in here and tweaks that number around. Now, our actual part of our strategy here is going to be void perform work. And we're going to say QList iWorker pointer and list. And if this seems dead simple, it's because we've done this over and over and over again. We say for each, and this is where we're going to say iWorker. It doesn't matter what kind of worker it is, as long as we can actually work with it. In our list, go ahead and, you guessed it, we're just going to say worker, and we are going to work. So down here, very, very simple. We can just implement this, and we're going to just say QList case sensitivity has come back to haunt me. There we go. So we're going to make a list of workers. We're going to go ahead and fill that list. Then I'm going to perform that work. And then because we have created some objects, we are going to, you guessed it, QDelete all, clean that list out. We could, if we wanted to, call list clear, but we really don't need to. I'm going to do it just because I've gotten into that habit over the years. Save, run. Let's see this in action. Sure enough, we have a whole bunch of workers here. So we have a construction worker, a surgeon, office worker doing their whatever office workers do, video games or whatever, and it just works. So you've probably done this multiple times and not even realized it. And yes, whenever I hear the strategy design pattern, I immediately go to, okay, you're going to make an interface. You can get a little more granular if you want. You can make this a little more complex if you want, but really under the hood, what you're doing is you're creating an interface that's going to glue everything together and make a nice, neat little function for everything to flow through. Okay, let's talk about the template method design pattern, and this is one that kind of peeves me a little bit. So define the skeleton of an algorithm in an operation, deferring some steps to client subclasses. Keyword subclasses. That's right, we're talking about inheritance. The template method lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. This is really, honestly, C++ Inheritance 101. You should already know this, but we're just formalizing this and calling this a design pattern. The base class declares algorithm placeholders, and the derived classes implement the placeholders. You guessed it right here. Here would be our base class. We have like step 1, 2, 3, and then our subclasses could re-implement step 2 or step 3 or whatever we wanted to do. Don't make this super complex. It's as simple as you think it is. So for example, you could have a worker, and then every subclass would also have a work to it. I personally don't like this. I don't really go for this. I tend to stick with interfaces, but Qt does use this. For example, QTCP server. We've seen this in previous examples where you have to implement a TCP server class, and then, you guessed it, implement all of the funness that goes with it. So let's take a look at a very simple example here. We have a chef class, and I'm going to just, through the magic of copy and paste here, really speed this video up. So we've got a chef class which inherits QObject. It's going to have a make dinner function along with a prepare, cook, and clean up. Now I could have very easily said, you know what, let the subclasses take care of this, but I'm going to actually go ahead and I'm going to implement these. So let's switch in and copy and paste just because it makes life super easy. Make dinner is going to prepare, cook, and then clean up, and these functions are dead simple. They're just really for illustrative purposes. Again, I don't want to spend tons and tons of time on this because this is C++ 101. We're going to go in here and we're going to take our baker and we're going to, you guessed it, inherit that chef. Let's flip in here. Now that we have got this chef, let's go ahead and insert virtual functions of base class. And you guessed it, we can implement those. We don't have to because of the way I designed that chef class, but we can. And ta-da! Let the IDE do the work for you. Life is better when the IDE does the work. So when we prepare, well, you guessed it, mix the cake ingredients. When we cook, you know what? I'm just going to say what everybody's thinking. Preheat the oven, bake the cake, let it cool, and extra frosting. I said extra because why not? And then cleanup, of course, is, again, I'm going to say what everybody else is thinking. Make the kids clean up. I don't want to do it. All right, so let's go ahead and make that a little pretty. Save all. Now we're in our main, and this is super ridiculously simple. Again, it annoys me that this is even a design pattern. Again, C++ 101, you should know how to do this. There are some little gotchas though, and this is what I really wanted to focus on. So if we jump back here, you'll see that people tend to overcomplicate this, and there's some general rules of thumb. So the strategy is like a template method except in its granularity. The template method uses inheritance to vary part of an algorithm. Strategy uses delegation to vary the entire algorithm. This is what I mean by it can really start to blur the line. Strategy modifies the logic of individual objects, and the template method modifies the logic of the entire class. Factory method is specialization of the template method. That is key right there. So what are we really saying? Yes, you've been doing this all along. No, there's no mystery to it, but you're going to hear somebody somewhere say, well, I made a factory method design pattern. They're going to try and sound super smart. Really, all they're doing is inheritance. Let's wrap this up by talking about the visitor design pattern. This one, honestly, is a little bit brain bending. It's so easy to screw up and, to be brutally honest, vastly easy to over-engineer this bad boy. So, represent an operation to be performed on the elements of an object structure, and visitor lets you define a new operation without changing the classes of the element which it operates. That sounds a lot like an interface. This is a classic technique for recovering lost type information. Again, sounds a lot like an interface. Do the right thing based on the type of the two objects, and we have this thing called a double dispatch. And you can read this very lengthy discussion about it. And basically, what it boils down to is you have a visitor and an element, and the visitor is visited and the element accepts it, and it goes back and forth into this really crazy dance. And this is probably the easiest example I can come up with. It's right off sourcemaking.com. Think of a cab company. So the cab company has an object structure or a list of customers. It's going to send a cab to one of those customers, which is a concrete element. The cab is actually a visitor. So, you guessed it, the customer is going to enter the cab, which is going to visit the customer, and the cab is going to transport the customer back. And if that makes no sense, it's because it makes no sense. I think this design pattern is over-engineered right from the start, and we're going to try to implement this, and it's not going to be fun. But I'm going to slow way down as we do this. So let's jump in here, and as we're doing this, think in the back of your mind, there must be a better way, because there is. There's always a better way. So we have double dispatch. We have an iVisitor class and an iElement class, but because they don't know about each other, we have to make a class prototype and then say include the actual class. Same thing. So in the element, we're going to say there is an iVisitor somewhere, and then go grab it. And then our actual iElement, we're going to say accept a visitor. So this example here, if we look at the cab company, is the customer. The customer is the iElement. We're going to do a shopping cart. So think of this as a product. The visitor, in source making examples, a taxi cab. This would be our actual shopping cart. And this is the visitor. So the visitor is going to visit an element. So the shopping cart is going to go into that element and say, how much are you worth? Seems like there's a much better way of doing that, and there is. I'm sure you can come up with dozens and dozens of examples just in your head. And that's why you don't see this in modern times very often. And if you do see this, you have to stop and ask yourself, is there a better way? All right, I'm not trying to dog the visitor pattern. I don't like how convoluted it is. It makes a lot of problems. So let's go ahead and implement these. So I'm going to say class. We're going to make a cart. And I'm going to just add some includes for our cart here. And we are going to implement the public iVisitor. So right click, refactor, insert virtual functions of base class, and the iVisitor will visit an iElement. So our shopping cart is going to visit a product. Let's switch around here, and sure enough, in our visit function we have a pointer to an iElement, and we're just going to say something to the effect of the amount is whatever the amount is. Pretty simple, pretty straightforward. So all we're doing is we're visiting that element to gather some information. That's why I don't like how convoluted that is. All right. Let's go ahead and make some sort of product that we can sell. We're just going to call it a shirt. Could have been fluffy bunny slippers or whatever we wanted. Let's go ahead and grab some includes out of my notes. We're going to include those two interfaces, and of course, now we need to implement the public element. Right-click, insert virtual function, and we're going to do the accept. We're going to accept the visitor. Think of this like opening the door and say, please come in, and the visitor is going to come in and hang out for a while. Now we can switch over to the source here. And this is where things are, well, a little murky. This is where you can very easily break things. And honestly, I'm just not a huge fan here. Did I forget that? I totally did. My apologies. There should be a private variable in here. All right, should make that go away. Let me fill this out real quick, and then we're going to have a little conversation about the accept function here. In this design pattern, accept is where the magic really happens, and that's why I'm slowing way down for this. So what I can do here is say, all right, prepare for a visitor, and then we're going to set some value, and this could be like file IO or something of that nature. I'm going to say maybe. File IO maybe. We're going to get this value from somewhere. It could be a database, could be a file, could be whatever. And then the visitor is going to visit this object. We're going to say, okay, now we have a visitor. Think of this in terms of like you're going to open the door, so you clean your house in a hurry, you have a visitor, they come in and look around, and now once we get to this point, the visitor is now left and we've shut the door, and we're going to clean up because the visitor made a big old mess, and we're just going to say, okay, revert this back to whatever we need it to be. This is really the core intent of this design pattern, is we want to be able to visit some sort of element, get some information or make some modifications, and then leave. That's why it's called a visitor, because a visitor eventually, we hope, will leave. Sometimes you get visitors that never leave, and they're always annoying. So let's go into our main. Now we have our cart and our shirt. Let's go ahead and create some of those. I'm going to say cart. We have our shirt. And the shirt is going to accept our cart. Again, it's kind of backwards from what you think. You think the cart would accept the shirt, similar to the on sourcemaking.com, the cab example. You think it would be the other way around, but it's really not. Okay, so let's run this and see this in action. So the shirt is preparing for a visitor, which is our shopping cart, which is going to get the amount. And then after the visitor is left, the shirt's going to clean up after the visitor. That's really the intent of this design pattern, and honestly, that's why you rarely see this in Qt applications. I'm sure it is used out there, and I'm sure it's used heavily, but when you get into Qt applications, we really don't do this a whole lot. We'll use signals and slots, we'll use members, we just won't use this most of the time.